slides in there, and I think today what we're doing is we're primarily talking about joins and some, I call this advanced queries, but really what we're talking about is like joins, where we are talking about combining the contents of different tables together. Now the reason why you want to do that is because you may have information in two different tables, and you need some quick and easy, convenient code that you can use to pull that code or pull that the contents out of each of these tables and somehow mix them together in some convenient way. And so that's what we're talking about today. We're talking about the connecting of information from different tables. And so that's what I mean by joins. So let's go ahead and just get started here. I think that anyone out there who is a Beatles fan, I think that you might appreciate this slide here. Come together. This is really what joins do. They bring together pieces of information from these tables. And so it's kind of like you're coming together. You're bringing things together. You're combining records of different tables. And so that's really what this is all, this whole class is about today. And so they call those in SQLite, they call those joins. You're joining together two different tables. And let's see here, your join tables, when you're joining a table, you really get something that looks like this. And so on the left, the left here, you have a join called, you have a left join, you have a right join, and you have a full join. Now, it's kind of tricky here to see what's going on, but we'll go through it. But when you have what's called a left join, where you're combining a table which is, it's called, the word left is what they call it, this join. But the table that I'm looking at on the left here, where we have x1, x2, x3, and on the right I have y1, y2, and y3. When you are combining these tables together, the x table and the y table, you have to find some kind of, again, some kind of relationship. You have to say, okay, what is my relationship? How do I bring these tables together? How are they connected? And so in this case, we're using the key. And you can see that the key in these tables, the key is on the left for the x table, 1, 2, and 3, and the key on the right for the y table is 1, 2, and 4. And so the left join is using the left table in this diagram to bring together the tables such that you have, you're saying, I need to have the information from, I need the matching information from x1, x2, and x3 in the y table. So in other words, I'm combining x1 with y1, x2 with y2, and x3 with y3 here. But the thing is that we're using the, not the x's here, we're using the keys, the 1, 2, and 3, those keys from the x table, and 1, 2, and 4 from the y table. But you'll notice that on the extreme right here, when you combine these tables together, you can pair the keys 1, 2, and 3 in both tables, but you'll notice that there's no information for key number 3 in the y table. And so therefore you have this missing piece of information. And now that's dangerous when you're working with databases here and you have missing data, because that data might be something that you really need, like maybe it's login information, maybe it's banking information or something. And so you really have to be careful about your data that may go missing. But in this case, so you can see how that when you zip the things together, according to the relationship, the ID or the key ID here, which is 1, 2, and 3, there is no 3 on the other side. Instead, we have 1, 2, and 4. But since we're using the left-hand side of the X table to lead this union, we're just picking 1, 2, and 3, and not 4. So that's why we have this missing placeholder in the Y table here, because the keys come together, but where key 3 comes together, there's no value for Y. Now, a right join is very similar in that you're using now not the left table to lead the union, but you're using the right table to lead the union. So in this case, we have tables for the Y table. I have keys 1, 2, and 4, and I don't have a 4 key in my left-hand side table, which is the X table. And so you'll see that when the keys are actually combined, or when you pull the keys here from the Y table, and then you try and find their matches in the X table, you'll see that you have 1, 2, and 4 from the Y table, but because there is no 4 key in the X table, then you have, again, missing information. And so it's kind of like your zip is coming together, but there's teeth missing so that it doesn't come together perfectly. It's not a one-to-one. This is actually a problem when you deal with tables where, for instance, you have most of the keys are the same, but other keys are not the same. Now, then you have, and you guessed it, you have what's called the full join, where you just put together all keys from both tables, where they match, and where they don't match, you have missing information. And so, for instance, here, on the X table, I have 1, 2, and 3, and the Y table, I have 1, 2, and 4, and you can see that I have all my keys in the table on the extreme right here for that union table, I have 1, 2, 3, and 4, but you can see that there's NA, and that stands for missing data, not available. I think that's what they call it. But NA is not available. It's data that's missing. It's just you don't know what it is. And so you can see that for key 3, the data is missing for the Y table, and for key 4, the data is missing for the X table. And so that's one of the things you have to deal with when you're joining tables together. Now, the reason why I'm actually mentioning this is because if you are pulling data from different databases to create a super database, one of the big problems that you always have is finding matching pieces of information. So you might have database A, which you find from somewhere online, database B, which is another place that maybe it's your own database you're cultivating, and you're trying to find some way of pooling this information together such that you have one giant table. Well, that's where you run into trouble, because if you have missing data or they have missing data, then you can see these rows are incomplete. And if you need complete rows for your work, then that becomes precarious. Right, so this is in Venn diagram form. These are what these joins actually look like. And the code here is written on the bottom. It would be nice to be able to, anyway, but you can kind of get an idea about how it's nice to be able to see how the tables actually do come together. And so, for instance, on this, I'm looking at the left-hand side table here. This is a join. This is a left join type of scenario, where you can see that the information is primarily coming from the A table, and any overlapping information is B is then brought into the union. On the right-hand side here, this is a right join, and you can see that B is now leading the union here, and so anything that any matching information or any correlated information in A is brought into the union when you use the right join. Then you have other types of joins here too, where I think that the middle join A and B, that's the intersect, where you see this kind of filled in red spot in the middle. That's your intersect. That means all the common information between A and B. This is another kind of query. We can write all these queries in SQL, so we actually pull out information such that we get either the union, we get left joins or right joins, or the intersections. And then of course you have I'm looking at the very bottom now, where I have A and B, and then everything is filled in. This is on the bottom left. That's what I would call your full join, where you're just putting in as much information as you possibly can, putting them both together from both of these tables A and B. And so you have the code next to it to kind of get an idea about how this all comes together. I think that the code is a little bit complicated just yet, so let's move on and discuss some lighter code, and then we'll get into this kind of code later on. So really what I'm talking about is these. I'm talking about our joins. There's a certain kind of join that we're going to talk about first. It's called the cross join, which is really what we've just seen, but it's matching every row of the first table with every row of the second table. Let's read this here. If the input tables have X and Y columns respectively, the resulting table will have X by Y columns. You can think of a cross as a kind of it's an exhaustive listing of all possible combinations, I guess, that you can get in a table. Then we have, or in two tables here, then we have the inner join, which creates I'll just read this again. This creates a new result table by combining column values of two tables. So you're using some kind of, I guess, a constraint here to pull information using one table to pull information from the other table. The query here compares row of table 1 with each row of table 2 to find all pairs of rows that satisfy what's called the joint predicate. The joint predicate, that's like your conditional statement here. I'm saying that let's use table A to lead the join. Any matching information you have in B, pull that over, and let's use that. So let's go through some simple code here. This is actually kind of an interesting piece. This is actually I like this one here. This is a database which stores values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we have J, Q, K, and A. Those are cards. And so what we're going to do is we're going to join together these values with clubs, diamonds, hearts, and spades to create a full set of cards here, just by joining. So we have two different tables here. One table is the rank, and the other table is the suits. And we can put together the rank and the suits to create, like, the ace of diamonds or the 3 of spades or whatever the cards are. I don't sound very, very good at cards, do I? So let's just go ahead and copy this out. I'm going to put this, I probably have to put this into my, oh goodness gracious, this is going to give me a problem. Okay. I'm going to copy this into my editor, just so you can see kind of what I'm doing. I'm doing that in case something terrible happens where I have to go back to my code and something terrible has happened. Everything's all over the place. Let me just go ahead and kind of undo this. I think that should do it. Join suits order. I don't know why I can't get spaces in this. This is just cray. Anyway, so that's that. I'm going to go and tell you what I'm going to do. I think I'm going to go to my, prompt here to put this into the, So I have to go to my terminal here, and when I get onto terminal, where is terminal? There we go. This is terminal. One thing I'm going to do is I need to actually get to my prompt here. So I'll just do this in this class docs directory. It'll be fine, I'm sure. Fall, I go to CS312, and then I go to class docs, lessons. And actually, I'll tell you something else I can do. Inside your thing here, you should have your Docker container. I'm going to go and just run my Docker. Hope you can see this. But when I run my Docker, I first of all want to type in build. And because I'm running a Mac, I have to use the Mac starter here. Now, this means that it's built my container. Everything is fine. Everything's put together. Now I just have to run my container. So basically, the car is running, but I'm not inside it yet to be able to drive it. So the next command I want to type in is run Mac. If you're using a Linux machine, you'd use Linux, run_Linux. If you're using Windows, you'd use run_Windows. And you have to make sure that you're using the correct command for whatever you're working with. There, now I'm inside my container. I can see that because it says root. So now that I'm in here, what can I do with this? Well, I'm going to go and just type in, for instance, SQLite 3, and I'm not actually going to do any work. I don't want to save this, so I'm just going to paste my work in there. And so it doesn't matter that I'm not creating a file name. That doesn't matter to me at all. But I will just leave that as it is. Let me just go ahead and let me go back to my slides wherever they are, and I'm going to copy this. You can't see what I'm doing, but I'm actually copying, or not my slides, but the stuff in my editor. And I'm going to try and paste this in here, and I'm going to cross my fingers and hope that everything works out well. Okay, so it does work. And so I have made, just disregard that for a second here. Let's talk about the tables. I have the tables. Let me just show you what's inside the tables. Select all from, and then we have ranks. And so these are my cards. 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, and Aces. What else do I have in here? Oops, not too many dots. And then I have suits. So select all from suits. And you see I have hearts, diamonds, clubs, and spades. Now let's go back to this piece of code right here. This is actually what we're talking about. So we have to create a new temporary table here, I guess. It doesn't stick around, but that's really what it does here. Oops. When you run this, sorry about that. When you run this code right here, you're creating a temporary table here, and inside that table, you're creating these values: clubs, diamonds, hearts, and spades. Oh, sorry. That's not the slide. That's not the temporary table. Let me go back and remove this. I'm getting ahead of myself. We're not making any. Okay, so we're not making any temporary tables just yet. Here, what we have is. This is actually the select statement that we have here. The other statement has an insert statement in it too. But here what we're doing is we're selecting the rank and the suit from the table ranks. And then this is the new table, or this is the new code right here, cross join. And what that means is you're starting with the ranks table, and then you're putting together each piece of the rank here as a kind of a Cartesian product of every piece of information you have in the ranks table with every piece of information that you have in the suits table. And then this piece of information back here, order by suit puts everything into kind of it puts everything into a numeric order according to the data that's in suit. So let me just show you what's inside. Let me just for my own sake here. So I'm ordering my information. Oops, I guess I'm dumping multiple pieces of information in here. Hang on a second. I've just corrupted my database. I'm going to recopy this in there just so I don't I don't make a mistake again. And this is why I would do this. Hang on. Going back here, I'm gonna, oh, you know what? You know what? I need to drop my table. Well, okay, fine. Actually, better way to do this is exit and then go back in again. Okay, so now I have this last command here. So what I'm doing is I'm looking at my table here, suit, and I'm ordering everything. So that means that basically it's going through and it's putting together these queries from both the tables together. It's zipping them together like a zipper, putting them together. In fact, you can't really see very well. I think I'm doing this. Something's being done twice here, but really, what it's doing is it's kind of putting together the numbers from the card numbers and the Jack, King, and Queen from the suits table, or sorry, from the ranks table, and it's combining them with the suits table. It's not a great example, but it does show that we're kind of making a Cartesian product where we're just like X. If we have table X and you have table Y, then this is this thing taking X times Y and putting them both together in some kind of in a table here. All right, well, that was interesting. Let's move on to the things here. So you have this to play with if you want, but the new vocabulary that we're dealing with is this cross join, and that's just saying take the information from the first table, take the information from the second table, and zip them together like a zipper. And then this other piece of information down, or this other piece of code here, order by suit, that just makes everything come through in a kind of a sorted order. So that means that use the table suit and put everything into some alphabetical, or in this case, numerical, then alphabetical order. All right, the next one I wanted to talk about is this inner join. So that was the cross join, a kind of the Cartesian product. We're going to be talking about that again, so hold on. The next one I want to talk about is this inner join, which is the fruit join. Now, I do have this piece of code waiting for you someplace. In fact, if you see, let's get out of my deal here. You can see inside, whoops. Okay, I've just closed my container. I'm going to, actually, I'll tell you what I can do is I can go to, actually, where is it? It's going to be my lessons table for week 4. And inside my sandbox, you'll see there's this other thing right here. So I have my source directory in sandbox. You have the same directory there too. But there's a file here called fruit join. And you can see kind of like how fruit join works. In fact, I've done that so that you can avoid the same trouble that I had where you're trying to copy and paste things and the formatting is all off. But let's just go through this code for a moment here. We create 2 different tables, as you can see. There's table A and table B. And we have, remember, we're combining information in this join for which the information is the same in both tables. And so my first column that I have in my table A is going to be called fruit. And then I have color, and then I have table B, fruit, and then I have color. Now, in this table A, and yes, I am spelling color in the British English way, just to be more interesting. Why not? It's Friday, rock and roll. In my table, I have lemons, and I put this A to say that lemons is from the A table. But I also have lemons B to say that B, this is lemons from the B table. So then the next piece of information that I have in my table is the color. Both tables have color. Both tables are exactly the same. So I have lemons A, and then I have yellow, lemons B, and then I have yellow, and that's for tables A and tables B. Then I have apples A, which is red in tables A, and then I have apples B and red in tables B. But where these tables actually differ is this last line here. I have grapes A, purple, and oranges B, orange in table B. So now what we're going to do is we're going to combine these tables in a way that is going to be looking at the color and saying where the colors are correct, I want to see this whole tuple. So that is what this is all about here. So the constraint that we're dealing with, and I wish I could get this all in one line here. I'll just go ahead and put this into the thing. But the constraint that we're dealing with here is that if the colors for these fruits are the same, then we want to list them in our table. And again, I'm here in my source directory. I need to find my, in fact, I can stay in source. I can run behind me. I can go behind me and hit my run Mac OS here, and then I'm in my container again. And there we are. I can still see my files. SQLite 3, run that. I'm going to paste everything in here piece by piece. You can see this, everything's just been dumped in there. And what I see now is that the last query it's actually quite complicated for what it actually returns. It seems like there's much more text in the query than actually the actual result. But what it's doing is it's selecting the fruit from table A, the color from table A, the color from table B, and the color from and the fruit from table B. So there's that. And then you have to define, for instance, what the first table is that I'm leading with. And so I'm leading with table A. And then I have to have this code here called inner join. Inner join, and then I say, okay, well, now that I'm leading with A, who am I going to be adding, or who am I connecting my data with? And I'm connecting my data with table B here. I hope you can see that. It's getting kind of squashed out. Oh my gosh, you can't really see what I'm on. Well, I don't know if that makes it any better. Okay, that makes it better. But so I have this inner join, and then the inner join, I'll just make this big. So I have this this is the continuation of the same line here. Then I have this inner join, and it's saying, okay, so take the information from table A and use that as a lead, and then we use this inner join. That's the command that you'd have to say to kind of zip things together. And then it says to find information from B such that the color in B is equal to the color in A. And so this is just this piece of grammar that you have to have on. So when I first saw this query, I really didn't like what I saw. I thought it was actually quite complicated for what it is, and what it's doing. But then I thought to myself, how else would you write the query? How else would you be able to actually put this data together so that you can, or put the query together so that you can actually combine the data in this way? So if you just remember that when you're using this kind of query, you have your inner join, then you have to, or let's go back here. You have your table A, and then you have your inner join. Table A is the leading table. Inner join is the following table, and then you have this on, and that means like on condition that the color in B is equal to the color in A. And so when you run this, you see that, for instance, I have lemons A, yellow, and so this part is all from table A, and then I have yellow lemons B, and that's all from table B. So it's combining two different tables together. And then you can see that, for instance, apples A, which is from table A, apples, and then the red. And then I have apples B, which is from table B. But nowhere do you see anything about the grape color here. Select all from the table A. So for instance, you have grapes A and purple. Since there is no purple, or since there's no purple color in this database, the other color is orange, those two colors are left out. And so you can use this to combine, well, the contents of different tables where you have some kind of condition. The condition in this case could be something like, the primary keys have to line up. The name has to line up. A student and a class, you're combining a table in such that the student's name is actually in the registration of the class. You're putting things together. And so it does have some use. And so when you first see this, you're probably thinking, why would I ever need to know that? Well, because you might when you're actually working with databases, when you're actually finding a more specific type of query. Now, this is just more information here, so that you can when you look at these slides and later on you can see what the command was I just put in there. The inner join, and you're saying use this table A to lead. Then you have this join, then you have B that follows, and then you have on condition that this is true. And that's where you get this output, which is actually quite cool. It's actually quite sophisticated. The code that does that, I mean, if you wanted to write a piece of, this was actually written, or SQLite was written in C. So if you wanted to write some C code that would do that with data sets, that's actually quite a lot of code. That might be seemingly like a half a page of code to make that happen, or even more. And so it's actually not a bad thing if you think about it. You just have just a few words seemingly that you have to type in to get this thing to happen. But if you actually used C or even Python or something, it's actually quite a complicated maneuver computationally. But anyway, this is just some more Cartesian join stuff here. So we're looking at we're creating a table A and a table B here, and I wonder whether I've actually created these tables already. I doubt it. Where these two tables I'm creating have a number. That's all they do. They just hold a number. Let me just go ahead and dump these in my thing before I forget. go back to my database. I'm just going to leave all this information here, I think. Actually, maybe I should get out of this. If I get out and then I go back in, you'll see that everything is now gone. I can create my new tables, and I think that worked. Oops, it did not work. So why did that not work? It's because I'm copying and pasting things, and that doesn't always work very well. For some reason, copying and pasting text from these slides into this never seems to work. So I do apologize. So now we have this, so we have our schema here. So we have our two different tables that we just created. And now I'm going to put in some information. And the information that I'm putting into these tables is really rather boring. I'm just putting in numbers. Each table is really just holding numbers. You know, table A is holding numbers 1 through 4, and table B is holding numbers 1 through 9. So it's not hugely exciting in this database, but it is what it is, I guess. Table, let's see, table B, did that work? It did work. Table A, did that work? I always type in these commands when I dump in code into these because I need to be convinced that my code actually did copy or did actually populate my database. Let me just expand on that. When I'm copying and pasting information into a database, I could have made a mistake. In fact, it's very likely that I did make a mistake. You've already seen me make several mistakes copying and pasting text from my slides into this database here. And so when you copy and paste things in, things could be miscopied or something could go wrong. So I'm reminding you, please do run a very basic test just like this each time you copy something into a table to make sure that something actually made its way in there. Because if you're running queries, if I run tables now, if my table is empty and I'm running a query, I will not have any result. I don't have an error message either, though. And so I don't know, for instance, whether maybe did the query come up empty or is there no data in the table? Either way, I get nothing. And so you really need to know that your data is actually in those tables. Otherwise, it's going to you don't know where the error is. Your queries could be correct, and more than likely they are. And why not? This is Allegheny College. The queries are going to be correct. But what I'm saying is that your queries could be correct here, but there may not be any data in the tables to actually find, and so you wouldn't know that your query is correct. You just think that perhaps there's something wrong with the query, but you would never check to see that there's actually data in your database. So please do check that. Now we're going to explore this cross join a little bit more here, where this is a more simple example. I'm going to be using this code right here. So really what we have is table A and table B. And so your Cartesian product, as I call it, this is your x times y. So everything in table A is being paired with everything in table B. That's what this code should be doing. Or in this, sorry, if you go back to the slides here, everything in table A should be compared with, or should be connected with table B. So everything in A is paired with everything in B. Everything and everything in B is being connected with everything in A. And so you can see that this is kind of in graph theory, they'd call this a click, where everything is connected with everything. So let's go back and just run this and see what happens when we just place this code. I'm actually kind of excited. So you get a bunch of information here. But actually, though, there is a pattern that we can make out. So for instance, you can see that, let's just look at the right part of the column first. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is the information from table B. Table A's information is only 1 through 4. And so you can see that we're creating a kind of a product here where we have, this is table A's 1 row. Then next, and 1 gets paired with every element in table B. Then next we have 2, where everything is connected with B. Then we have 3, which is the next element in A, which is connected to everything in B. And then we have 4. And so you're really creating a Cartesian product of all of this. So this might be useful. You'll know it when you see it. Another way you could do the same query is, if you go back to the slides here, you'll see that you could run this code right here. If I can copy this correctly, that would be just terrific. I think I can't get that last semicolon, but I'll try and get it over here. So if I put the same code in here, it's the same thing. And so what I'd like to say, though, about this is that there's more than one way of writing a query in SQL. Just as we know in computer science, there's more than one way to compute some value. I mean, it's just the nature of the game. And so if you were working with your I mean, if you're working in your lab, for instance, and you're talking to your lab partner, and you see that their query that they're using to go through their tables is different from yours, don't despair. Do not worry, because it could be that you're approaching the problem from different ways, but the answers are still the same. And so stick to your guns and make sure that when you're actually running your queries, actually go back to the results and see whether those results actually do make sense for what you're looking for. And here, the result that I'm looking for is just everything in A is paired with everything in B, and it seems that that's what I'm getting. Everything seems to be doing that. So there are multiple ways, which is kind of, I guess, sometimes nice and sometimes not nice, in SQL, multiple ways of actually creating the same result. Okay. Alrighty. So the next thing here is we're going to talk about these joins in a little bit more with color here. It's really an example of exactly the same thing that we've been looking at before, but we're going to be working with an inner join on our data set. And so I'm just going to go ahead and copy this line. Hopefully you can see that. And so from the left-hand side here, what I'm expecting to find is I'm expecting to look at the blue table and the yellow table, and the results that I want are going to be blue and green, if that makes any sense at all. Hopefully it does, but if it doesn't, then just ignore it, and that's fine. But I'm looking at this Venn diagram, and I'm looking to find the results which come from the blue side and the green side. Now, this is kind of a I wanted to actually, the reason why I chose this example here is because you don't always get a result back. In fact, if something is missing, instead what you see in SQLite is a blank. Remember, if you go back to, let's just go back to my slides for a second, at the top here where I'm joining these together. Here we have NA, remember that? We have the NA, which means that it's not applicable, or it's not available, it's missing information. Sometimes you don't get that NA in SQLite, which is really annoying. And so sometimes you don't know whether something terrible has happened or whether there's nothing going on. And so going back to the result of this, chances are when you run joins, if information is missing, so what we're trying to do here is we're trying to do this, I'm looking at my on statement here, on condition that table A number is equal to table B number. Well, you're seeing that the numbers between tables A, let's go ahead and put them up again. So you'll see that the numbers in table A are 1 through 4. We also have 1 through 4 in table B, but table B also has some other numbers too. And so getting back to my original query, what this is doing is it's saying, okay, where the numbers are the same, in other words, for numbers 1, for numbers 2, 3, and 4, I can find those numbers in both tables. But there's a bunch of stuff that's in 9 that I don't have in 4. And so rather than telling me NA, it gives me the tables that exist, or the rows that exist, but then down here, I have all this blank space. That is SQLite's way of saying there's nothing there. It doesn't report NA, it doesn't report anything else, it just says blank, and that's all you get. And so be on the lookout for that as you're running your queries, because you don't know whether, for instance, when you first look at this, you just think, oh, there's nothing there. So I guess my query is only 1 through 4. Well, there's actually much more information to pull out of this, and that is that you're actually missing information like each line here where you have a blank space. You're missing that information. In fact, I think you can do a simple count. Let's try doing that and see whether we can actually get how many lines there were. Count. So I get 4. So actually, that means 4 results actually show up. But because I have all these spaces, that suggests to me that there's things being overlooked. That might be useful to you in the future, and you'll know it when you see it. I know that sounds really kind of like Obi-Wan Kenobi stuff here, but it's true. You'll know it when you see it. If you're working with joins and you suddenly start seeing blanks showing up, it could mean that there's actually pieces of information which are missing inside your. There's a bunch of stuff that's missing inside your code. Right. I think I've made that point. The right join, by the way, is just reversing the table A and table B. In fact, you can try that and see what happens. I think it's probably nothing too crazy. I'll just copy this. I'm going to go back to my where I'm working, put that in there. There we go. So when I did a right join, what this is saying now, start with table B. Well, what's in table B? Let me just show you what's in table B. Table B is, I have 1 through 9. Start with table B, and for each of these numbers, check them in table A. And where I find those results in table A, report them. And so you can see that there are no, getting back to this thing here, but there are no gaps, because it says that everything that I was looking for in table B here was found in table A. That means 1 through 4. Now that means I've exhausted table A, which just had 1 through 4. So I've exhausted table A, and that means that these values all were in table B. That's why there's no spaces here. Anyway, I think that if you just spend some time and just kind of play with the example here, it might help you to kind of get a kind of new respect for joins in this thing. But I think that it will make sense if you just look at it and spend some time and just play with the code here, and you'll see what I mean. We're now going to go on and do some what I call more advanced queries here. And so we have a new database that we're going to be looking at, which is a new look, same great taste database. We're going to go back to our here we are. We're going to go back to our campus database here. So it's our new look, same great taste database. And if you go down, you'll see that this is actually from your book. That's right, I stole this database from your book, which is not bad. This is the schema that the book uses. I didn't use everything. I just took these tables out here to put them into the database, but I mean, we could equally add all these other tables, but all the examples that we're going to talk about actually concern these blocks that are in red. These red boxes are the actual. You could use the you could take all this other information too, but the examples can be shown by these tables here. Okay, so let's move on here. So now I'm going to go back to my terminal. We'll talk about this in a second here. That slide. I'm going to leave SQLite here. By the way, I have to stress that when you are inside SQLite, this is a different environment than the environment where you are here. So that means that when I'm talking about going back, when you go back here and you see a command like this where you're doing this cat campus db build, that is a command that has to happen outside of SQLite. It does not happen inside SQLite. You have to use this at the terminal, which is right here. I'm not inside SQLite. If I were inside SQLite, I'd type in SQLite 3, and then I'd be inside and I'd see a prompt that looks like this. And so none of these commands from these slides here, none of those commands for compiling, for combining my builder files into databases, those commands will not work here. And so you have to actually exit this database, SQLite, and run your commands here. This is what they call the bash. And so when I'm talking about like running that cat command, it works out here. If I go into SQLite 3 and I try and type in cat, what's the file called? Builder campus db.txt. It's not going to work. It's not going to work, and I think a number of you have sent me Slack messages over the last couple of days here saying that they're having trouble building their builders. Well, please remember that you cannot build those files inside this SQLite environment. You have to exit the SQLite environment and then work out. Oops. You have to work out here in your bash. Okay, so maybe that's enough said there. I'm going to go ahead and I'm going to build my thing here. So remember, I can type in builder, and I always have at the end of the code here. This is where the tables are being created. Then I have the data is being inserted. But at the very, very end, for convenience, I always add this code down here so that you have an idea about how to actually use this file. So I'm going to go cat builder campus db text. I use the pipe command, SQLite 3, and then I'm going to give it a name, campus db SQLite 3. And then I'll get some error messages, which is okay. But the database, and that's just because some of the constraints are not happy because I'm trying to do things but we don't need to worry about that right now. But the database itself, though, is actually being built, which is right here. So we have built our database. And you then once you've built this database, check to make sure that the file has some space in it. That means, like, is there any data in there? So now it's like we have a suitcase in front of us, but we're actually like picking up the suitcase to see how heavy it is, to see whether there's anything in there. So now we can run SQLite3, and then we can call it campus database.sqlite3. And then once we get inside, the first command always should be table. Table. Do I have anything inside here? And then the next command you might want to run is just choose a table here. Select all from instructor to verify that there's data actually in there. I would recommend going through all tables, making sure that the data actually did make its way there. Because if it doesn't, then your queries are going to return, there'll be nothing to return, and you won't know why that's happening. Anyway, so you want to run those basic commands here when you get into your database, just to make sure that stuff is there. Now, if you have a colossal table, which is just filled with stuff, and you don't want to have all that stuff in the table coming out, let's say you have, like, 1,000 records or whatever it is. At the end of your select star from some table like this, you can type in the word limit, and I'll just put 3, some number. And then it just shows me the top 3 pieces of the top 3, I guess, rows in that table. So I can do that with each table I want, so I can just get an idea about what's. Just give me the top 3 things. And you do that just to check that there's actual data inside your system. Otherwise, you might find that there's no data in there, and that could be crazy. Anyway, so getting back to the slides here, we've built the database. We've used this command, which is actually very handy, I hope. We've used this command to build the database, and now we can actually start running some more advanced queries. The first thing we're going to talk about is a set operation for it's a union, or an OR, they'd call it. Now, how do you remember the difference between an OR and an AND? An OR is a union, and an AND is an intersect. When you say the OR, it's basically saying take the stuff over here and the stuff over here and combine them together. It's like you're adding things together. But when you use the AND, the intersect, that means it's looking at this table over here on the left and this table here on the right, and it's finding out the common information between both of them. I always remember the union as an OR because at my when I was in college, we had a building that was called we called the Union, and that was where we had the student center. That was where the cafeteria was. That was where the bookstore was, and basically everyone would go there just to hang out. So all the students would go there and hang out in this building, which we called the Union. So I just imagine, like, all pieces of information coming to a union and just kind of coming together and staying together. You're not excluding anybody. Everyone's just coming together. And so the union is really kind of adding things together. Now, it turns out that we have some built-in union commands inside that we can use for our tables. So let's see. We have our database. Make sure everything's there. Yep. So I'm going to use this union over here where I'm going to be looking at. Oops, I find that there's a space missing here. But what I'm doing is I'm looking at the instructor table. And I'm looking at the course table, and I want to find out what is the common department name for both of these things. So let's just go back and do a search here. So let me just show you what's inside each of these tables. Select all from instructor, and then I have select all from course. And hopefully you can see everything on one thing here, but in the instructor table, I have comp sci, oops, I have another comp sci, I have math, I have comp bio math, and so on and so forth. And so those are my departments. In fact, you can see the schema here for the you can see that I'm looking at the department name right here, varchar. Then in my course, let's look at the course schema for a second here. I have the department name here too, which is the third one along. And so if I look at my course, it's this information right here. So I have, like, for instance, comp sci, English, and French. So getting back to my original query that I put in here, this query is saying, okay, we'll go through each of those tables here and put together the union of each of those. Oops, goodness gracious. There we go. Go through each of those tables here and give me like a just name each department once. Like give me the distinct union of whatever's in there. And so looking at both of those tables here, we have Comp Bio, Comp Sci, English, French, and Math. Notice it just lists each one of these things once. It's like the distinct value of this. But what it's doing, though, is it's just checking to make sure that it just goes through each of these tables, selects the department name from instructor, and then it's also selecting the department name from course. Notice that these are actually two different queries. Select department name from instructor, select department name from course, and then we have this word union in the middle, and that just says run these two queries side by side. First do the instructor, then do the course, and then union these things. So I can also do the same thing with, I think, with intersect. In other words, tell me what's common to both of these. Excuse me. So again, I'm running a query where I'm saying select all from instructor, all department names from instructor, select department names from course, and then whatever I find in these two outputs, intersect them, and then report that to me. And so this is really what this, this is really just two queries happening with this intersect word between them. And you can see that the only thing that comes out is Comp Sci, and that's because each table, I guess let's go up here. Course I have English and French, and I don't think I have English and French in instructor. It's yeah, so I don't have English and French in the instructor table. And so that suggests to me that the intersect is just Comp Sci. Anyway, I'm hoping that you get an idea about how you can perhaps use these things later on. You might be looking to to somehow sort your data in a database and then to pull that out and then to do something else with it. Well, now you don't have to write code to actually sort the data for you. Sometimes you can just write a query and everything will just be done for you. So it's the information that comes on your screen, you can just pour that into, say, some analysis program or something else. So it's it does make things kind of convenient. Again, we've discussed this distinct here. I think that this goes through the department name of instructor, and it just tells you whether something's whether some department name has been mentioned multiple times. It just returns one iteration of that name, and the same thing happens in course. And so now what we're going to do is we're going to do the same kind of thing here. Where we're going to use the except. I'll just put it up here and see. You can see what it does here. Oops! Oh, goodness gracious. Select department name. There we go. So the except thing here, the except command here returns distinct rows. Oops, I guess you can see this. I'll put this back in a second here, but it returns distinct rows from the left query that are not in the output of the right query. And so going back here, when I run this command right here, you can see that it's saying select everything from the department name from instructor, then select the department name from the course, and now tell me what's different between these things here. That's for instance, what's in the course or what's in the course table that's not in the instructor table. So you're now able to do. Let me just go back to these things here. Now you're really using. You're actually able to do these Venn diagram. These ones here. These are commands that we're using to actually kind of isolate data in this kind of fashion. I think that we're out of time here, but please do spend some of your own time here going through some of these queries. I think sometimes they just make more sense if you just sit down and play with them. Than having me kind of like going through the code here. But do spend some time actually just kind of going through these queries and convince yourself how they work, because I think that once you see how they work, then it's just easier. It's just easier to actually implement them or to think of ways of using them. So play with the code, and if anything, remember, if anything happens to the code, if you damage your database in any way, then it's no big deal, because again, you can just use this command cat builder and rebuild your database, and you're good to go. Alrighty, are there any questions anybody may have? All right then, everyone. Stay safe. I'll see you all on Monday.